Hey, seventh grade. So our learning target for today is I can evaluate expressions that contain square roots. So you should be on page 32. Page 32. Okay, so we're going to start by talking about what a perfect square is. So what is a perfect square? Well, as you can see, these are the perfect squares. 1 squared, 5 squared, 9 squared, 2 squared, 3 squared, 4 squared, 6 squared, and so on. All of these, I'll highlight all of them, are in what we call perfect squares. Hopefully you recognize a pattern there and that you would be able to continue that pattern to 13 squared, 14 squared, 15 squared. So what we're really saying is a perfect square is a square. So if you have a 3 by 3 squared, you have this number called 9. Now 9 becomes what's called the area. 3 times 3 makes 9. Side times side gives us an area of 9. So what we're going to learn about today is how we break it apart. So if we're given the area, what we're going to find today is what would the side length be? That's kind of how square roots work. So we're starting with talking about perfect square. A 1 times 1 square has an area of 1. So we're really talking about the area of the square. A 2 times 2 square has 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. So those are what we call perfect squares. So if we just grab one of these out of here, let's say this one, and we would say, well, that 36, which is the area of the square, is perfect because it comes from a 6 by 6 square, because 6 times 6 has the area of 36. So what we're going to do today, as I mentioned, is we are going to talk about perfect squares, and we're going to talk about how you find a square root from the perfect square. So everything is coming from the word square, and it really does mean the shape of a square. So this first one means if you have this symbol here, this symbol right here means square root. It means that there is a square. I have a square that has an area of 9. Your job when using this symbol is to find out what is the side of the square. What is the side of the square that has an area of 9? You should say that the side of the square is 3. So the square root of 9 is 3. Next example then, we have a square that has the area of 64. This symbol right here is asking what is the side of the square? What has to be true about the side of the square to have an area of 64? Well, the side of that square had to be 8 because 8 times 8 is 64. Now notice I'm not writing 8 times 8, I'm just writing 8. So the square root of 64 is equal to 8. Next example. We have a square that has an area of 100. That's the area of the square. What we want to know is what's the side of a square in order to give you an area of 100. The square root of 10 is, or square root of 100 is 10. The square root of 100 is 10. So our answer there would be 10. So that's called the square root. What we're doing is trying to find the side of a square. So let's take another example from the mix. So let's say 4 is the square root of what? So what was the square that gives you a side of 4? So we would say that the square would have to have an area of 16 in order for the square root to be 4. So the square root of 16 equals 4. So the way we would write it over here then is the square root of 16 is equal to 4 times 4. Okay, so let's take a look at what's called a negative square root. So I like to teach this as like negative friends are waiting outside. So all your negative friends are waiting outside. Let's first do the inside. So we do the inside of the square root because the order of operations says that you have to. So we have this square. It has an area of 25. So we have a square that has an area of 25. We would want to know what would be true about the side of the square that has an area of 25. Well, the square root of 25 has to be 5 because the only way to make this square is 5 by 5. Now notice I'm just writing the number 5. I'm not writing 5 times 5. Then what we're going to do is we're going to grab that negative friends waiting outside, and we're going to reattach it to the answer. So we solve first, reattach negative. So the answer to that problem is negative 5. It's called the negative square root. Let's take a look at the next example. So we have this square that has the area of 81. What we're doing is trying to find the side of the square. What's the side of the square that has an area of 81? So we have the square root of 81, which is 9. So this has to be a 9. And then we're going to take that negative and we're going to reattach it. Negative 9 is called the negative square root. Okay, guys, take a look at the next example then. So in the next example, we have a square that has the area of 400. I know that looks like a rectangle on my screen, but I'm trying to draw this on a tablet with this little tiny pen, so it's kind of hard to draw in this space. What we're asking about, what's the side of this square that has an area of 400? This would have to be a 20, because 20 times 20 makes 400. So that's a 20. We're going to take that negative and we're going to just reattach it to the answer. The answer is negative 20. Those are called negative square roots. So what happens if it's not perfect? So we talked about all the perfect ones. They're listed above in yellow. But what if they're not perfect? So which ones aren't perfect? So if I just go through this list real quickly, say, well, we said 1 was perfect because it's 1 times 1, and 4 was perfect because it's 2 times 2, and 9 was perfect. So this is 1 squared, and this is 2 squared, and this is 3 squared, and this is 4 squared, and so on to infinity. What's true about the square root of 2, and the square root of 3, and the square root of 5? Well, those are not perfect squares. Not perfect. So we'd have to estimate when we have something like the square root of 32. We'd have to figure out, well, where is the square root of 32? Well, we know the perfect ones, so I'm going to list them over here on this side are 1, 4, 9, 16, 25, 36, and so on. Okay, so the square root of 32 actually lives between, so if we go ahead and highlight this here, square root of 32 lives between the square root of 25 and the square root of 36. And the beauty is we know those. We know that the square root of 25 is 5 and the square root of 36 is 6. And 32 is right in the middle of those. So it's between the square root of 25 and the square root of 36. So we know our answer is between 5 and 6. So our answer is $5 and so many cents. We'd have to estimate that, but that's how we would know how to guess our answer. 5 point something something. Okay, so number 17, or the square root of 17 now. So the square root of 17 is between the square root of 16 and the square root of 25, somewhere in between there. And we know what the square root of 16 is. The square root of 16 is 4. So it's between the square root of 16 and the square root of 25. And the square root of 16 is 4. And the square root of 25 is 5. So our answer is $4 and some cents. $4 and some cents. Okay. So let's take a look at the next example. Now I'm going to go back through and erase these so we have some empty space. But we're going to use those again, thinking about the perfect square roots, the ones that are super nice. 1 times 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81, and so on. So the square root of 35 right here, we have to approximate because it's not perfect, but we know it's in between 25 and 36. So we say that the square root of 35 is in between the square root of 25, which we love, and the square root of 36, which we love even more. So if you take the square root of 25, we know it's 5 because we're just looking for a square that has an area of 25. What's the side length of that square? The answer is 5. Notice I'm not saying 5 times 5, I'm just saying 5. And then over here we have this symbol, which just means we have a square that has the area of 36. What's the side of the square? It's 6. So our answer is between 5 and 6. 5 point something. Somewhere in here is my answer. So we'll just leave it like that for right now. Between 5 and 6. $5 and so many cents. All right, let's take a look at square root 51. Square root 51 lives right here between the square root of 49, which we love, and the square root of 64, which we love. So square root of 49, love that one, and square root of 64, love that one as well. So the square root of 49 is 7, and the square root of 64 is 8. So my answer is somewhere between 7 and 8. So I'm going to say 7 point something something is my answer. 7 point something something. How we doing, 7th grade? I hope you're feeling okay with these estimations. They're not always super easy for kids because it is a little bit of a guessing game as to where it lives. All right, square root of 72. So we're looking for a square that has an area of 72. The bummer is that's not perfect, but we know that it lives between 64 and 81. So we know that the square root of 64 is on the left-hand side of that, and the square root of 81 is on the right-hand side of that. So then the square root of 64 is 8, and the square root of 81 is 9. So my answer is somewhere between 8 and 9. So it'd be 8 point something something. Go ahead and catch up if that was too fast. Okay, so now what we're going to do for the rest of this lesson then is talk about the order of operations with square roots. Order of operations with square roots. So I want you to think about that. What changes in 7th grade math is this parenthesis really has two options right now. It's either a parenthesis like you're used to, or it's a square root. And then it goes exponents, multiplication, division, addition, subtraction. So what's new for today's lesson is that the parenthesis is not only normal parenthesis like you're used to, but it's also a square root. So that's first place. All right, so here is my first place. This is working just like a parenthesis does. Order of operation kicks in. Now I have these negative friends waiting outside. I'll reattach them at the end. So I have some work to do. First of all, inside I'm going to do this power. That's 2. That's 2 to the 3rd power, which means I need 3 of these. 1, 2, 3, which is 2 times 2 times 2, which is 8. So that becomes 8. So I'm going to rewrite everything else. We have 17 plus 8. If I haven't used it, I drag it down on the outside of the square root symbol. Now we still have that square root there. And inside the square root, I'm going to be doing the operation of addition. So that's 25 in the square root, negative friends outside, plus 11 on the outside of the square root. We're going to take the square root of 25 and we get 5. And we're going to reattach the negative. So that becomes negative 5. Negative 5 here. If I haven't used it, drag it down, plus 11. Answer is equal to 6. Everybody should have 6. Okay, order of operations on the other side. We have please excuse my dear Aunt Sally. Keep in mind that the parenthesis now is also a square root. First place now is the square root symbol. So we're going to do all the stuff on the inside first. We're going to do that multiplication first on the inside. So that gives us 35. So we have the square root of 35 plus 65. If I haven't used it, I drag it down on the outside of the square root symbol. Inside here, I have 35 plus 65, which is 100. So I have the square root of 100. If I haven't used it, I drag it down, plus 16. The square root of 100. Oops, sorry if I'm going too fast. Go ahead and pause the video if it's just way too fast. The square root of 100 is 10 plus 16 gives me 26. Answer should be 26. Everybody check your work there. 26. Okay, so let's keep rolling here. Order of operations down here below. Remember that this square root symbol is functioning like a parenthesis. It has to happen first. So we're going to do all the stuff on the inside. We have addition and addition. So we're going to do addition from left to right there. This says I have to owe somebody $3 and I have $9 in the bank. What happens if I have 9 in a bank and I'm going to take 3 out? Can I do it? Yeah, I can do it. That leaves me with 6, positive 6 left in the bank, plus negative 2. 6 plus negative 2. Now, inside of there, 6 plus negative 2 becomes $4. The square root of 4. So remember, I have a square that has an area of 4. This is what this symbol means right here. What's the side of the square? You should be saying that the side of the square is equal to 2. Answer is 2. How we doing, guys? All right, this next one has a whole bunch of stuff going on. Please excuse my dear Aunt Sally. You know how to do that. Please excuse my dear Aunt Sally. Remember that in today's work, there is a tie for first place on that parenthesis and that square root. We have both going on in this first problem right here. So I'm going to start by doing this negative 14 plus 7. Thinking about that, I got to pay somebody $14. I have 17 in my bank. Can I do it? Yes, I can, which gives me $3 left. I'm going to go ahead and get rid of that parenthesis. I don't need the parenthesis because it's not negative. $3 left. And that power 2 gets reattached to the problem, but that's still inside of a square root. If I haven't used it, I drag it down. Inside that square root, I have to take care of that power first. That's 3 squared. Inside there, I get 9. And then I'm going to take the square root, reattach, subtract 2. All right, guys, the square root of 9. Think about the square root. It means that there's an area of 9. And I'm trying to find the side of a square that has an area of 9. Gives me 3. 3 minus 2 is equal to 1. Answer is 1. Great job today, guys. Almost done. All right, here we go. Order of operations with some square roots, some negatives, some triangle problems. There is a whole bunch of operations going on in this problem. So we're going to start by doing just this little piece right here. And then I'm going to rewrite everything else. We might run out of space, but we'll figure it out. Inside here, this becomes a 2. And this over here becomes an 8. 13 minus 5. There's a multiplication sign in between. So I end up with, on the top, 2 times 8. Go ahead and look at that. Make sure you're comfortable with what I just did. Because of space, I'm kind of combining a few steps at once. I said I wasn't going to do that, but I really am tight on space. I bet you are as well. In the denominator, then, I have this multiplication that has to happen first. That is a triangle problem here. So we have a triangle problem. We have a negative on that 8, and a positive on that 2 gives me a negative 16. A negative 16 here. All right, so let's clean up what we have. Numerator has been taken care of. We have this square root of, and I still have this 2 times 8 happening. Square root of 2 times 8, so I've covered that. In the denominator, I have 12 plus 16. So I'm going to rewrite that denominator. 12 plus, I'm sorry, that was a negative 16. Okay, because we changed this to negative 16. In the numerator, that's 16 living inside of a square root. In the denominator, my deal is this. I have $12 in the bank, and I'm trying to take out $16. I can't do that. I can take 12 out, but I can't take 16 out, which leaves me with a negative 4 in the denominator. Okay, so the square root of 16 means this. We have a square that has an area of 16. That's what the symbol means right here. I'm trying to find the side length of that square. The side length of that square would be 4 over negative 4. And that's a triangle problem right here, which is equal to negative 1. Answer should be negative 1. So what we've done today is the order of operations with square roots, negatives, exponents, everything that we've done. We've added square roots, and the key idea is this. The key thing that you have to keep in mind is that square roots are in first place. They're actually, I should say, tied with parentheses for first place, left to right. Okay, guys, so that is your homework piece for tonight, is being able to do that. You only have 1 page of homework. Your job is to do the homework page 33 for tonight. Have a fabulous night.